So, Chapter 6 is Elasticity. And again, much like Chapter 5, it's one of the more interesting chapters in the book, but it's sometimes a little difficult for students. So, I really want you guys to pay attention in this chapter and get some of the concepts and theories that are going to be thrown at you here. Elasticity. We're going to go through all of it, and let's first define it. And usually when we talk about elasticity or inelasticity, we're talking about the price elasticity of demand. And that's basically it's a ratio of the percent change in quantity demanded to the percent change in the price as we move along the demand curve. What that means really is how much will quantity demand change if we change the price of something. And you saw earlier we're going to drop the minus sign here. We will for price elasticity of demand, and that's only for convenience. Going by the law of demand, anytime you change price, if you increase price, you are going to drop demand, right? So in theory, all changes in price will lower quantity demanded, which means it would be negative. Just because it's inconvenient to just have all these negatives a lot of times, or just basically all the time, when we talk about price elasticity of demand, we drop the negative sign. So how do we calculate this? Well, you can see here it's the change in quantity demanded divided by initial quantity demanded will get you a percent change in quantity demanded, and then the change in price divided by the initial price will equal your percent change in price. There's your numerator, there's your denominator, here and here. So if you're not good with percentages, I suggest you brush up on that because we're going to do a lot of that in this chapter. The first example the book gives is the demand for vaccination. As you can imagine, vaccines are pretty inelastic, and if you haven't read the book chapter yet, you don't know what I'm talking about, but we'll get into that in this discussion. So when the price rises from 20 to 21, point A to point B, the quantity demanded falls, and this is kind of, don't pretend this 9.9 is over here and this 10 is over here. So when the price rises from 20 to 21, the demand falls from 10 to 9. And again, pretend these is just shipped over here. So from point A to point B, what has happened? We're going to calculate our price elasticity. So the percent change in quantity demanded, we had a change of negative 0.1 million vaccinations, that's 100,000, divided by 10 million. That was the total number in the first part. So that's minus 1%. So that's a 1% drop in vaccinations when the price rises. The price change was $1 when the original price was $20. So that's a 5% price increase. So what does that mean? That means our price elasticity of demand is going to be 1% divided by 5%, which is 0.2. And if you've read the book chapter and gone through some of the studying, you know that's a pretty inelastic price elasticity of demand. If you haven't, we will find out what that means in a little bit. The midpoint method is another method, and it could be complicated. I don't want to scare you off. There's a lot of equations here. But generally, and if you look here, it's just plugging and chugging. That's all it is. Q2 is your second price, or second quantity, first quantity, and you get the divided by the average of the quantity, and you take that number and you divide it by this number, which is your change in price, or your second price minus your first price divided by your average price. Looks like a lot of stuff going on here. It's really simple. Just plug and chug. If you have your initial quantity, your second quantity, your initial price, and your second price, you can figure this out. Do not be afraid of this. So look here. We have situation A and situation B. Price of 90 cents and quantity demanded is 1,100. If the price was $1.10, your quantity demanded is 900. So we found your change in quantity demanded, plugging and chugging, and we found our change in price. So it's minus 20% divided by 20%, and it looks like, and again, if you go by price, the equation for price elasticity of demand, you have your percent change in quantity demanded divided by your percent change in price. And again, here is where we use that midpoint method. And that's 20% divided by 20% equals 1. That is a perfect unit elastic demand. So, what is the difference between elastic and inelastic demand? Well, inelastic means if there is a change in price, there's going to be a small change in demand. If it's elastic, when there's a change in price, there's going to be a larger change in demand. Generally, when the price elasticity of demand is less than 1, we call that inelastic demand. You could see eggs, beef, stationary, gasoline, and that's pretty interesting. I mean, like if you think of eggs, 0.1, very inelastic. People want to buy eggs. If eggs go from $1 a dozen, as it may be on sale at Easter, to $2 a dozen, as it may be normal price, the other than the Easter, general Easter sales, people who would normally buy eggs would still buy eggs at $2 a dozen. There are zero close substitute for eggs, so we'll see some of that effect later too. Elastic of demand, you can see housing, restaurant meals, airline travel, foreign travel. These are going to be higher than 1. The price elasticity demand higher than. Well, that means a small change in price in foreign travel. If the price of foreign travel increased by, say, 10%, you would see a drop in demand in the quantity, probably a lot larger than 10%. We'd say probably if it's 4, that's 4 times. We'll say 40%. That's a huge drop in demand. That's a huge elastic demand. Now think of, I know a lot of people have problems determining and trying to remember the difference between inelastic and elastic demand. I always like to think of it as an elastic band. If you stretch the band and it is very elastic, that means it's very responsive when you stretch it. So, like foreign travel is very responsive when you change the price. Beef, for example, is not as elastic. So this hypothetical rubber band or elastic band is inelastic. It won't stretch that much. If you change the price of beef, if you raise the price of beef 10%, the quantity demanded would probably not be 10%. It looks like it would be a little less than half of that, so maybe less than 5% drop in demand. We are a species and nation that likes to eat beef, myself included. So there isn't much change there. So I hope that helps you determine a little bit what the difference is between inelastic and elastic demand. So let's look at some 2 extreme cases of price elasticity of demand, where it can be perfectly inelastic when the quantity demanded does not respond at all and changes the price. That would be a vertical line. And the demand is perfectly elastic when any price increase will cause the quantity demanded to drop to 0. That would be a perfectly horizontal line. So shoelaces is an example of price elasticity of demand, perfectly inelastic demand. No matter what the change in price, there's going to be the same amount of shoelaces. I think a better example, and I think the book gives this, is snake venom. If you are bitten by a snake, if it costs $2, you're going to buy the snake venom. Or antidote. I'm sorry, not venom. The antidote to snake venom. If it costs $2, you're going to buy this antidote to snake venom. If you are bitten by a snake and it costs $3, you are going to buy the antidote. No matter what. If it costs $100 and you are about to die, you are going to buy the antidote for snake venom. So the increase in price would leave the quantity demanded unchanged. That is a perfectly vertical line. I don't like this example of the price of pink tennis balls per dozen for a perfectly elastic demand, which would mean at exactly $5, consumers will buy any quantity. At any price above $5, quantity demanded is zero. Any price below, quantity demanded is infinite. I think a much better example is if you think of say the break room in your place of work. You go in your break room and you want to buy a can of Coke. There are two vending machines side by side. The one on your left, vending machine A, has the can of Coke for say $1. Vending machine B also has the can of Coke for $1. If vending machine A rose, its price rose from $1 to say even a penny more, $1.01. In theory, most people would buy all the cans of Coke from vending machine B. The quantity demanded in vending machine A, if it rose its price from $1 to $1.01, would be zero. Because why would you spend that extra penny? I know it's only a penny, but just think in theory here. You didn't have to go anywhere else. They're right next to each other. You would go into vending machine B. At any price below that, the quantity demanded is infinite. If, say, vending machine A charged 99 cents instead of $1, you would not buy, you'd be crazy to buy it from vending machine B. Now, again, a penny isn't a lot of money, but think of it in larger terms. So any change in price would affect the quantity demanded tremendously when there's a perfectly price elastic demand. I hope that makes sense. So, again, if the price elasticity of demand is greater than 1, we call that elastic. There's a lot of give. A small change in price will lead to a large drop in demand, or larger. Demand is inelastic if the price elasticity demand is less than 1. And the demand is perfectly unit elastic if the price elasticity of demand is exactly 1. So let's look at the price of a bridge crossing. So a 20% increase in price here would lead a 20% decrease in the quantity of crossing. That would be unit elastic demand. There's an even percentage change between the price and the quantity demanded. Now, granted, they're going in opposite directions, but again, that's our law of demand working. For inelastic demand, and let's look at this curve. It's kind of, I wouldn't say straight diagonal, but it's looking somewhat straight diagonal, and that's a unit elastic demand of 1. So look at the inelastic demand, and you can see it's pretty steep. It's pretty vertical, and you'll notice that about inelastic demand curves. And you could see the effect here. A 20% increase in price would lead to a 10% decrease in the quantity of crossings demanded. It's inelastic. There's not a lot of give. There's not a lot of drop in demand and quantity demanded when the price increases. You take that to the other extreme with elastic demand, you can see it's less steep when it's elastic. And you'll look at the change here. A 20% increase in the price would lead to a 40% decrease in the quantity of crossings demanded. So there's a lot of give there. It stretches, to give that example of the rubber band again. So again, does it matter whether the demand is unit elastic, inelastic, or elastic? Yes, because this will predict how the change in price of a good will affect total revenue. And this brings it back home to how this is applicable to those of you who will be in business when you graduate. So total revenue, again, is price times quantity sold. Don't confuse this with profit. Total profit would be total revenue minus total cost. We're just looking at revenue here. And the price elasticity of demand really affects total revenue, or at least changes do in how you do this. So let's look at the bridge crossing again. Your total revenue is price times quantity. So at 90 cents per bridge crossing, there will be 1,100 people per day crossing that bridge. So you will get a total revenue of $990. So elasticity and total revenue here. If the seller raises the price of the good, there's two different effects that will happen, except in the rare case of a good with perfectly elastic or inelastic demand. There's the price effect and there's the quantity effect. So the price effect says after a price increase, each unit sold will sell at a higher price. That makes sense, right? If you raise the price, each unit will sell a little higher, and that will raise revenue. But the quantity effect, of course, because of the law of demand, after the price increases, fewer of these units are sold, which tends to lower revenue. So let's look at the effect of a price increase in total revenue. So here is, and we're not going to say what if this is elastic, inelastic, or anything right now. So the quantity effect of the price increase means fewer units sold. You can see in part A, or rectangle A here, you see the effect of the quantity effect. Rectangle C is the price effect. The price is higher for each unit, so you'll get a little more unit there. So the question is, which is going to be higher, A or C? Now, we're not determining it on this slide right now, but so you'll see if the demand for a good is elastic, as in the price elasticity of demand is greater than 1, an increase in price will reduce total revenue. The quantity effect is stronger than the price effect, and that makes sense. If you go back to the example of, say, foreign travel or airline travel, I don't remember if we saw that. So 4.1 was airline travel, if you remember, or foreign travel. And that means it's elastic. The elasticity was greater than 1. An increase in price reduces total revenue. The quantity demanded will drop tremendously if you increase the price of foreign travel. If the demand for the good is inelastic, go back to eggs or beef, for example, higher price will increase total revenue. So the price effect, the more money you get per sale, is stronger than the quantity effect, which is the drop in total sales. So if the good is unit elastic, the price elasticity demand is exactly 1, it's a wash. An increase in price does not change total revenue at all. They kind of offset. So let's also look at the demand schedule in total revenue. The price elasticity of demand will change itself along the demand curve. So you'll see here at this point, it is exactly unit elastic, and that's usually where you'll see your equilibrium, is in the middle somewhere. As you move along the demand curve, you will see demand is elastic at these higher price. A higher price will reduce total revenue. So as you move up here, the more you increase price, you're going to lose revenue. At this point, and this isn't a case of every demand curve, but in theory they all work this way, because obviously these prices and quantities are going to be different. But on the further end, the right-hand side of the demand curve, you're going to see demand is inelastic, a higher price. So say you go from $2 to $3, or whatever that is, you're going to see more or an increase in total revenue rather than a decrease until you get to this middle point here, and then it starts decreasing total revenue, which makes sense, I hope. So price elasticity demand is determined by a few things. Generally, whether close substitutes are available is one. You'll look at, again, go back to the eggs example. As I mentioned earlier, it was 0.1. That's way inelastic, that is. There are not many close substitutes for eggs. I know there's egg beaters, there's egg whites, that sort of thing, but generally not much of a substitute there. Whether the good is a necessity or a luxury. Foreign travel on the other spectrum is a luxury, of course, so that would make it very elastic. Eggs really aren't a luxury, and it's just a food item. The share of income spent on the good. Again, look at the eggs versus foreign travel again. You do not spend a lot of your income on eggs. If you do, you maybe need some help. But foreign travel, I mean, I've only gone out of the country a couple of times here, and it was kind of expensive when I flew to, say, Mexico. The price, the airline flight to Mexico is a lot more expensive than it would be from, say, Chicago to Orlando, even. And that's a popular. That's within the boundaries of the country, and it's a popular vacation destination. And time. A good example of this is gasoline. If gasoline rises, when it rose from, say, $2 to $3 a gallon, everyone complained, but everyone, you still have to drive. You still have to get somewhere. But over time, and now we're, near $4 a gallon as I record this, which is horrible. But, over time, so say in the first few months of a price increase, you can't do much about it. You still have to get to work. You still have to get to school if you're unlucky enough and you aren't in an online class like you are now. But say a year or two from now, if you're thinking about buying your new car, you may buy a car with higher miles per gallon. So that may change your use of gasoline. So over time, things are more elastic than they are in a short period of time. That's a funny cartoon, I guess. Oh, going back to the gas example. So there's also cross-price elasticity of demand, which measures the effect of one good's price on the quantity demanded of the other good. And think substitutes and complementary goods. So the cross-price elasticity of demand between good A and B is the percent change in quantity A divided by the percent change in price of B. Goods are substitutes if this cross-price elasticity of demand is positive. If this cross-price elasticity of demand is negative, they are complements. And this is where we bring back the minus sign when things are negative. Remember, we dropped that minus sign when we were talking about price elasticity of demand. When we go back to cross-price elasticity, we bring back that minus sign. So we're going from kind of a baseline of 0. So if the cross-price elasticity of the demand is above 0, the goods are substitutes. You could substitute them out for each other. If it's negative, below 0, these goods are complements. They complement each other. Think hot dog and hot dog buns, that sort of thing, and ketchup. Income elasticity of demand is another thing, and that's the percentage change in quantity demanded over the percent change in your income. And then that goes back to our normal versus inferior goods. So when the income elasticity of demand is positive, this good is a normal good. That means quantity demanded at any given price increases. So think vacations in general. You go on more vacations as your income increases. So that would have a positive income elasticity of demand. Ooh, say that 10 times fast. When the income elasticity of demand is negative, the good is an inferior good. Again, think of public transportation. As your income rises, your demand for public transportation, such as the bus or whatever, would drop. And there's also the price elasticity of supply. We've talked about demand, and demand is usually what you think of when you go through elasticities. But the price elasticity of supply is the measure of responsiveness of quantity of a good supplied to the price of the good. So as we move along the supply curve, these things changes. Suppliers may not want to supply that good as certain things change in price. So here's some two extreme cases. Your price of cell phone frequency. there's only a limited amount of cell phone frequencies. So whether the government charges the Verizon or whoever $2,000 for a cell phone frequency, or $3,000, excuse me, an increase in price really won't change the quantity supplied at all. So that's a perfectly inelastic supply. You remember that kind of correlates to the perfectly inelastic demand. Let's look at the price of pizza. So that's a perfectly elastic supply. So at exactly $12, producers will produce any quantity of pizza. A price below $12, if they can't get $12, they are not going to supply any pizza. At above $12, it's going to supply as much pizza as you want because they have the advantage, I guess, over the other pizza producers. So again, and there's a perfectly inelastic supply when the price elasticity is 0. So the changes have 0 effect on the quantity supplied. That's the vertical line, and the elastic perfectly elastic supply, is the horizontal line that we saw as well. So the availability of inputs, if the inputs are readily available and can be shifted in and out of production at a relatively low cost, is one determinant. Time, the elasticity tends to grow larger as producers have more time to respond to a price change. They can more, in the future, for over a span of 10 years, combine more factories, for example. They can't really shift production over the course of a month. So the elasticity of supply in the long run is much higher than the short run. So, and here we have, and this was also in our e-text, so we won't really go over the menagerie of elasticity. A lot of things were covered in this chapter, so I hope you guys got it all, and I hope this makes sense.